So good day, everyone, and thank you for joining. Um, Today is our first regular meeting for the YakRover project, and for this first round, we start off with discussing operating systems, as it's a topic that we are all interested in, and also because it could impact us in different ways. In particular, it should be a topic on which we should be able to collaborate more closely and maybe build something bigger. I have a few slides to start the discussion, and at some point, I think Venkatesh will talk about a teaser about some perspectives he already talked about last year, but a bit more advanced now that the foundation on Netflix foundation is passing. And but most of the time should be about, I think, a discussion among us on the topic of operating system. And so to start, it's just a quick review of a few of the key things we talked about last year. Okay. Because I realized that over the year, at several all over the year, at several occasions, we went back to this topic. Okay. And at the beginning, I think a lot of us entered this group thinking that maybe we would just be using something called RoS, called the Robot Operating System, which is a beloved project by many. Okay, but it has several issues. So especially when we think about things like error handling and monitoring, it's a lot of work to get them to work in a project. I want to go into detail here, so it's just glossing about the topics that we came across last year. RoS is now about the second generation, and it's sometimes called the industrial RoS, and it's driven for some topics that are a bit different from us, typically warehouses or arm robots and stuff like that. And so that plus the fact that it's not really a real-time OS, we're not very sure whether we need a real-time OS, and we have some different point of view on some on where to go. Okay, it seems a lot of our discussions are about not using RoS. We talked also about free RTOS, which is a real-time operating system. We talked about one that provided by NASA called F Prime, that is used in some of their missions. I forgot the name. I think one of the missions is called Viper, to go to the moon. Using it, if I'm not mistaken, there is part of it also running on Ingenuity, something like that. It's open source. I don't remember exactly why we did not take on that one, but what was clear over the year that there was an interest in topics like autonomy and flexibility and even reuse. I forgot the term of reusability. Okay? So autonomy is and flexibility too, but especially autonomy is quoted because it means a lot of different things depending on what we're talking about, whether it's robotics, AI, or even philosophy. Okay? But over the year, so I chose the three keywords, robotics, AI, and philosophy, because it seems to me that a lot of things we're talking about is at the intersection of the three. Okay. Another aspect is that we've talked about what an operating system could be, but really from scratch. Okay, and something that is pretty interesting, and for that I will point to the notes, to the presentation and notes from Venkatesh that was last year. Okay, it's linked at the bottom of the page of this slide. Okay? But what is very specific here is that it sees an operating system from a very different light. Okay? And so recently from Tesla and Lyft, there were these papers and presentations called Software 2 and Autonomy 2, okay? Where we've been talking about the different lights at the YakRover. Okay? And the point that is really data-centric. Okay? So it's a new way of, well, maybe not a new way, but a different way of seeing what an operating system could be. So these are things we touched about last year. And this new year, we are focusing more on, we'd like to have more collaboration. And since operating system is a topic of interest under different angles, maybe we will be digging more onto these different points. Just a quick thing is that what is an operating system after all? Okay. So if I take the Wikipedia definition, it's pretty good actually. Okay, it's a software that manages computer hardware, other software, and every services you have on your computer. Okay. We have very good examples on all our computers: Linux, Windows, Mac OS. But for example, ROS 1, okay, which is the beloved one, okay, is also an operating system. Okay? More strictly speaking, a lot of people will call that a middleware. Okay, but if we look at the definition from Wikipedia, yes, ROS is an operating system. Okay? It's just depending on basically where we stand. Okay? ROS 2 is also an operating system, as well as Android, which is actually a fork of Linux, iOS. I'll be talking later about something called Balena OS. Okay? These are operating systems. Perhaps you've heard about something called QEMU. Okay? QEMU is a popular emulator that runs on Linux basically, and provides Android emulators and a lot of things like that it is very powerful, but that's not an operating system. Okay? Docker as well and Kubernetes are not operating systems. So in terms of terminology, sometimes we hear about middleware, frameworks, virtual machine, containers, and operating systems. Okay, so under the definition at the top of the slide, these words can sometimes be interchangeable. We can use one for the other. It depends. We have to be careful, but something we need to clarify at some point. Okay? So a possible simple definition of an operating system is that it's software. It's really software. Okay? And the goal of this software is to deal with the computing resources. So in terms of technology, it's the CPU, but it's also any devices you have, including sensors and actuators. But this simple definition may be simplistic in the sense that here, you replace OS by middleware. It just works basically. And an operating system is also a framework. And with that, a VM and a container would also be an OS. Okay, so it's a bit difficult. But anyway, aside the definition, which is basically terminology, a deeper discussion was given by Venkatesh last year. And here you have a link if you want to have more detail. We will review part of it here today, I believe, and probably go a bit further. In parallel, we'll be taking notes, so everything is in Rome. It will be linked later.
Quick point here. I think the last time we talked about ROS, we actually had some debate about whether or not it should be considered a operating system, because even though it sort of manages hardware at a higher level of abstraction, it really is more middleware. It's like a message passing kind of like network, right? It doesn't do low-level control of hardware. So I'm inclined to put a X next to it, like not consider it an OS, like by that definition.
Yes, and so that's something that I don't think we want to spend too much time discussing on that. It's just that I see that, but the thing that it really depends on the point of view. From the point of view of a robot developer, using ROS, the operating system is ROS basically. It's like what is the difference between the Linux kernel and the Ubuntu distribution? Okay, Ubuntu is for many people it's an operating system. Okay, but in fact it's a kind of middleware on top. It's a package of the Linux kernel, which is the operating system by many definitions, plus a lot of things around it, which are facilities on how to more easily use the Linux kernel in typically a desktop environment. Okay, and so for the Ubuntu user, yeah, Ubuntu is the operating system, but for the purist, they may say, okay, no, it's actually the Linux, it's a Linux operating system sweetened by the Ubuntu package. That makes sense under this slide.
I would just like to comment that when I learned operating systems, one of the most important, there were two very important functions for an operating system, and they were to protect the computer hardware from the users and the programs, and to protect the user from the hardware. So the first one is, for example, not to let the user run software which would cause damage to the hardware. In a Rover, it's obvious how you can do that. And the other one was to prevent the user from doing things where the hardware would destroy his data or do things like that. And again, in a Rover, we can definitely imagine those things. So this important protective layer, this function, I think is especially important in a Rover where you can actually have physical damage, and it's not mentioned here. And yes, it's weaker in Linux, but still in Linux, it's not so easy to write a program that unintentionally causes a disk crash. Okay.
Today, yes, but
No.
in the 90s, Linux would crash.
No.
You would have a core dump, but like all the time, basically. Okay?
But the disk wouldn't get damaged. It's not as if the hard disk would spin too fast and the spindle would move and it would get damaged, or the CPU would get overheated and burn out. These things didn't happen. Some was hardware protection, but some was software protection. So I'm just saying that these functions, in my mind, are in the operating system, and more important, a Rover doesn't have the opportunity to just shut down and start up again, and we cooled off and now everything is fine. Because if the Rover walked into a swamp unintentionally, that's it.
I would like to add to the operating system discussion, especially since we're talking about the free RTOS, which is a very, very low level kind of operating system. The two things that get brought up in operating systems very frequently are the notion of scheduling and priority. That is a core point that I think many people commenting on what RoS is, whether or not it's an operating system or an operating framework. RoS on its own does not provide any mechanism for prioritization or scheduling. It is completely left as an exercise to the user or the system architect to introduce that into a system that's built using RoS. But even free RTOS, that's actually kind of the core functionality it provides, is the notion of threading at a very low level, which can otherwise be very, very tedious for the programmer. Because as Mayor said, you're trying to protect the hardware from greedy code that's trying to spend all the cycles, so that instead of realizing it's time to stop and roll off the cliff, you're focused on some division by zero. So that is one thing about RoS, is it doesn't have the notion of prioritization and scheduling.
Thank you, Joshua. But under that light, so there is an abuse of language then, because we say that typically Ubuntu or Debian are operating systems, but they are not. The operating system is Linux. Is that correct under that light?
I don't know what people say in Japan or France, but in the US, the common terminology is distribution. Like people say Ubuntu is a distribution, yes. And Linux. I don't think that confusion exists, as in people understand that you mean Linux as packaged in the Ubuntu form factor. So I think that's kind of like more cosmetic confusion that people might have. Whereas RoS, I think there's actual like substantive reasons to not call it an OS. And yeah, what Joshua said was roughly what I was also thinking, and I think this came up before as well, that since ROS runs within Linux as a process, in particular, it cannot actually do time management and prevent preemption. So Linux can like issue a higher priority process interrupt that kind of interrupts the ROS process. And therefore you can't actually do, it's not even just that it cannot do real time. It kind of like doesn't have deterministic control over the resources it manages. So it's like, it's got a bigger boss. So that alone, I think, makes it not a candidate operating system. Like, to me, it seems like the operating system should be the most basic program running in the system after the firmware. Like after the bootloader, you've got firmware bootloader, and after that, it should be whatever you call the operating system. If there's more layers before you have what you call an operating system, it doesn't have enough control over the system.
I'd also like to suggest adding QNX and VxWorks to the list, as they are both used in these sort of embedded applications. And I believe VxWorks has run several spacecraft as well.
I'd like to ask Joshua, what do you think? I mean, you gave the example of falling off a cliff while dividing by 0. But if we look at the rover as something which controls its movements, how many programs do you think are running at the same time?
In a typical spacecraft, or like a rover?
In a rover, yeah.
Like a current generation Perseverance rover.
Yeah, and when I'm talking about programs, I'm meaning programs that have to do with controlling the hardware. Obviously, in the plain software, you know, paging and who cares what, you could have hundreds. But I'm talking about programs that are doing something with the rover itself. How many do you think are running simultaneously?
I would think on the current generation, and this is a completely uninformed opinion, so just work with me in my armchair opinion here. It's probably in the hundreds of processes, and this is the notion of a thread that's waiting to do something. And I say hundreds because even the current generation Mars landers are running a pretty old school traditional aerospace approach, which is to have a single radiation hardened processor that does everything. And so I think it's like a power PC with, I don't know, like 500K of memory or something from 10 years ago, but radiation hardened. So that single chip is doing everything. It's at the lowest level, measuring voltages and batteries and temperatures so it doesn't freeze to death. It's also thinking about transmitting its radio, and all of that is still happening on the same processor. So it's very important to be able to have flexible prioritization and scheduling to make sure everything happens in the right order with the resources. Because a lot of things like cars, for instance, there's lots of computers. There's hundreds. So it's a lot easier to have a computer that handles low-level things be very dedicated and disconnected from a computer that does very high-level things that don't matter as much, like the radio and the infotainment. But on these spacecraft, it's all the same chip. So it's imperative that the priorities are in alignment.
So there are more computers on a car than on a spacecraft?
Oh, yeah.
Yep. I think even 10 years ago, I heard a count that there were like at least 40 things that could be called, many of them were microcontrollers, but like 40 that could be called like, low-level computers on the CAN bus. So, yeah.
Which CAN bus? Now we have many CAN buses.
Yeah, this was when CAN was new and it was UART was kind of just getting replaced. I think this was like 15, 20 years ago. I listened to a talk about it. Oh, by the way, the Perseverance is running not a 10-year-old chip, but a 24-year-old chip. It is a 1998 vintage PowerPC. So I don't think it's even multi-core. I'll have to look it up.
Pre-iPhone.
Yep.
Yes. No, it's not multi-core. The PowerPC 950, right?
Yep.
The hardened version, by the way.
Yeah.
So,
okay.
Yeah. So thank you for the clarification. I do remember now the discussion we had. It's just you know, for example, when you go to AWS and you select your image for your new server, you know, you have a list of OS and you get Ubuntu, Debian, and so on. Okay, and there is this latent confusion about mixing the distribution and the OS. And I've just made it here on this one. But here there is different perspective. Is that when we talk about an OS formally, like we've just did now, which is the best thing to clarify. You know, we talk in terms of scheduling, in terms of resource management, safety of the system, and so on. Okay, all right. But when we are talking about developing software for a robot, do we want to take in those terms? We want to keep on talking in terms of scheduling, in terms of resource management, and so on. I think one of the success of ROS and maybe the will to call it an operating system is because it provides an abstraction at a level that is more convenient for the robot software developers, basically. So, is it something that is valid, and or is it something that, from our perspective, is not what we want to, not how we want to see an OS, and we want to see an OS as a formal.
I think first we should assess whether we think ROS is a success or not. I think by my standards, when I compare to what Linux did to servers, or Windows or Apple did to PCs, I don't think it may have claimed the label of OS, but it didn't actually work as an OS. As in, most people who build robots, more than half of them, I would guess, don't use ROS. They kind of like just roll their own. Like ROS wasn't available when I was last doing this stuff, but even now when you talk to people, it's like, yeah, half of them are just doing their own thing. Even in this group, a couple of people have tried ROS but haven't actually settled on it. So I would say it's trying to claim the label but has basically failed. So in that sense, I would say one hypothesis is it failed because it actually couldn't live up to the label of operating system in the sense that we've come to expect it. Like, I don't try to write my own operating system for a laptop or a server, but for a robot, even though I'm not a computer guy, I look at ROS and the definition and I'm like, I can't use this. I'd rather write my own simple scripts and run it directly on Linux than use this. So by that standard, I would say it's a failure.
Please explain why you feel that way about ROS. That not when I say feels that way, I mean that I'd prefer to write a few scripts on Linux than use ROS. That comes to the heart of usability.
I mean, I heard the couple of discussions we had, then I went and looked at the documentation, and it seemed to do a lot of middleware level management that wouldn't become relevant until a lot of basic functionality had already been covered. Whereas when I'm like programming, say, a simple Arduino or something, it's like small script, flash it to the board, and suddenly a motor starts turning. It's not even immediately clear how to even get that far to that hello world stage with ROS. It's like all kinds of conceptual clutter has to be understood first, and then you have to wonder whether it's actually worth dealing with all that to get a motor started, right? So that's kind of my thought. And when I looked at the BeagleBoard libraries, it was like, all right, this is more my speed. There's a library, it's got a bunch of scripts for like turning motors on and off and LEDs on and off. That's kind of the starting point I would expect. So in that sense, maybe it's because we are building toy hobby scale robots that it's the wrong, so it might be an impedance mismatch, but I don't think so. Like it seems like middleware. It seems like something I would use once I got past a certain complexity of base building, which means it's I wouldn't consider it an OS. But I don't want to get bogged down in definitions. But the basic point I wanted to make is I would argue that ROS has not been a success. It may have claimed the label of operating system, but as of now, there is no such thing as an operating system for rovers or robots. Like everything that's in the previous slide that Eric showed, you either have like bespoke NASA things that they've kind of like custom built, and that looks to me like these things that the NASA stuff that we talked about, I think a year ago at this point. It reminds me of descriptions I've read of like PDP-1 operating systems, which are like pre-operating systems. They didn't even completely control the system. So it's like, as far as I'm concerned, it's a category with a name, but no actual candidates that own it. At least to the standard that I would say Linux or Windows or Mac OS owns the category of this is a real operating system for a computer. Nothing meets that standard of like comprehensiveness for rovers or robots.
So
that said, ROS is the high watermark, undoubtedly.
Okay.
So let me ask, what would a low world operating system look like? What's hello world? The Rover works forward in waves, might not have arms.
When I think of like when I first learned Unix and learned some basic shell commands like, ls, you log on to a Unix command for the first time and whoever is teaching you says, all right, type ls and it'll show you a list of files, right?
Yeah.
And that gives you a very intuitive place to start working the file system abstraction. Like I imagine logging onto a robot and saying something like ls or some other very basic Unix command and seeing like a list of like motors and sensors or like some basic orientation abstraction. And then I can say things like, again, going back to the Unix abstraction, you might see like, a file, a text file, something dot text, and then you might say cat xyz.text, and then it shows you the listing of the file. What's the equivalent for a motor? It could be something like, forward one step, like the kind of command you have for your spider. Like that level of very basic, you just log on and you start like feeling your way around and sort of feeling the contours of what the robot is and what it's capable of. That I don't think is available yet.
Okay.
Like, unless you program it very carefully as a bespoke thing for a particular robot.
So let me take that a step further. Do you think hello world is you tell the robot walk forward one step and it walks forward one step and bangs into the wall? Or is that you tell it walk forward one step, it sees a wall and moves sideways? Which one would you consider to be the basic hello world?
So that's a good question. And I think it's one worth sort of working through the implications of, because if you look at like the next simplest thing, something like, just a dev board, the typical hello world program is the LED blink, right? And the LED blink is basically a completely safe program. I can't think of any situation in which blinking an LED will cause an unsafe failure condition. So this again tells you this is kind of like a basic question with Rover or robot operating systems that ROS does not answer. Like what should be the basic hello world? And I think I would guess it should be a safe behavior, but if safety causes so much like clutter to be required to even get started, then maybe safety can be sacrificed. Maybe one step forward is allowed to bump into things. So that's, I think, a good question. This is why I wanted to like introduce a thread of the 3 laws of robotics, because I think that's actually a surprisingly good way to think about these questions.
Just a second, there's 2 separate things. One is it's really difficult to set up and configure ROS. I'm ignoring that. You did it. Somebody did it for you, gives you a robot with ROS. And now you want to do a command, which when you give it to the Rover, you will be convinced that the entire stack of the Rover is working, and that you're able to give it an instruction and knows that it works. I mean, that's the basic idea of a hello world. In order to do a hello world, the compiler has to work, the terminal has to work, the printer has to work. Okay, so
Yeah.
And you were conflating that it's a big headache to get ROS to that point. But let's say somebody installed ROS on your robot. And let's say ROS had a terminal, which maybe it does not. What kind of command would you want to give it? And say, okay, I did hello world on my ROS. It works. Now I have to spend 10 years learning.
I'm not sure I see what okay, so there's a couple of different perspectives here. One is as a supervisor of the robot, like using the operating system to tell it what to do, as opposed to a designer of the operating system, which would be a Linux kernel programmer, bringing it up to speed on a particular robot. But I think one of the things I would want, so now I'm thinking purely as a supervisor or operator of the robot, same as I'm an operator of a Linux computer and I've never written Linux kernel code. So as an operator of a Linux computer, I log in, I expect to have the same interface in all Linux computers, regardless of like chipsets and things like that. And I expect something like, LS to work, like, just or CD to a new directory and do LS. I expect those kinds of basic things to work. So rather than use Hello World, which is an abstraction for programming languages rather than operating systems, I think we should use in terms of like the equivalent for Hello World is in operating systems is I think file system navigation commands. So for operating systems, all of them have like different file system navigation commands. We may be getting away from the file system abstraction in modern operating systems, but something equivalent to that for robots. So I would say a good Rover operating system should have a way for an operator or supervisor to log in and very quickly get familiar with whatever the equivalent of a file system abstraction is, which might be something like, Linux itself uses the file system abstraction even for controlling peripherals, right? You read and write ports like their files or something. But for robots, it might be something like I do an equivalent of LS and I see a list of like sensors and actuators. Maybe I can, I don't know, do a test like, maybe there are commands that are already known to be safe, something like self-test or diagnostic or something like that. And deploying ROS on 2 or 3 different robots should not lead to completely different, like, supervisor or operator interfaces. That I don't know. Maybe it's already true that all robots that use ROS have like a very similar interface. I don't know. Is that true? Or operator interface?
Not at all.
Okay, so that tells me it's not an operating system because there's only 3 operating systems across all the like PC class devices in the world, and we all know how to use all of them, right? Most people know how to use Macs, PCs, and well, engineers know how to use Linux as well. I don't think I could walk up to an arbitrary robot that's already set up and figure out how to operate it.
Most of them don't have an operator interface. It's part of the operating system.
Oh.
I mean, think of a real-time operating system. I don't know, VX. Maybe it doesn't have an interface at all.
That makes it another question. Like, is it more like what are the like Erlang, right? Erlang, it's a crash-only kind of language, and it's used for telecom switches. And the assumption behind the design is it's people rarely log in, and it never gets shut down. So maybe we need to clarify that kind of like assumption for a Rover operating system. But sorry, I didn't mean to derail this. I just wanted to. The big point I wanted to make is, do we consider ROS an actual success in sort of living up to the label of a Rover operating system, or is it, as Josh has said, at most the high water mark, not really a success as a operating system, I would argue it's not really a success.
Well, you haven't been derailing the discussion if that's what's happening by yourself, because I'm really interested in knowing what the group feels, what they expect to see in an operating system. So just for example, the people who expect to see a user interface in a autonomous robot. Is that, an expectation?
It depends how you see the user interface. It could be something like a voice command
Still a user
interface, right?
Yeah. But that's the question was, do you expect to see one? Okay, because saying ROS is not a OS because it doesn't have a user interface, I'm, simplifying the argument here. That's fine. My children don't have a user interface,
That's a good money trail to go down then. Like, we don't have an operating system type interface to all the animals in the world, but in general, if you are walking around in the forest or something, you have like a set of like, I don't know, default reactions. If it's a snake-like animal, you suddenly become more wary and step away. If it's a cute, cuddly rabbit, you might want to like creep up to it and take a closer look. So we have like almost a basic classification of kinds of animal and a set of like default behaviors that we trot out in relation to like millions of species of animals. We don't have millions of reactions to the millions of animals we encounter. Like, we've got scorpions, snakes, rabbits, dogs, cats, elephants. We have like maybe, I would say, 15 or 20 at most reactions to animals, right?
But okay, so how does that map to a Rover user interface? I mean,
good question.
You have cats and they chew your cables. You try to train them into having a user interface, which we know is very difficult in cats. Okay. But basically the user interface is some sort of basic learning series that if you give them positive reinforcement, negative reinforcement, give them an easy path to go, a difficult path to go, they will somehow react accordingly. So is that a user interface?
I would say so, yeah. Basic behavioral stimulus response is one pattern of operating system. Language is another. So spoken voice commands, like Eric mentioned, that's another modality. And I would say for robots, since they're not actually animals or children, and they are designed artifacts with like, the equivalent of like a brain connection, yes, something like logging into their brain and opening up a shell terminal, that's also one of the possibilities. It's like that's a class of robots. So there's a class of robots that you can sort of interact with through external behavioral modes. There's a class of robots that you interacted with by basically logging in and taking over their brains.
Quick question
So,
about
really-
the word. Please.
I just wanted to make the point that a fundamental challenge of robotics, especially in the notion of a interface or a standard, that is robots are extremely fragmented. They're heterogeneous. There are hundreds of thousands of different robots that have been designed or built, and they're usually catered around a specific set of tasks or objects or physical media. And so this is why it's like, is ROS successful? Well, I mean, how do you build something that can handle such a fragmented demand? It's a fundamentally different problem from an operating system, which is completely homogeneous. I mean, the interface is well defined, keyboard, mouse, screen. If you can connect to that, you've had success. But robots are so bespoke and usually pretty low volume too.
How about I say it like this? A robot has a metaphor. A rover has a metaphor. I don't care what it is now. The user interface is what allows you to interact with that metaphor. And the hello world is seeing that the metaphor is acting appropriately. So if the metaphor is a creature that can move and not bang its head, hello world is telling it to move and seeing that it doesn't bang its head. And it doesn't matter if it's walking or swimming or flying through the air, all of these still have a metaphor, and the user interface, to the extent that it exists, means that you can interact with the metaphor and get the result you expect. A simple one, yeah, it's hello world. It's not a.
I like that. And I think that also gets at the point Joshua just made, which is because of the variety and diversity, if you focus on a species of robot, in our case, rovers, so since we're trying to make a rover operating system, then that allows you to build, there are greater chances of coming up with a consistent single interaction metaphor. Because if you wanted to do all robots, it's probably impossible to come up with a single metaphor that fits them all. But there's a good chance that a single metaphor will fit all rover robots in at least a good approximation way, like, 80-20 rule, something like that.
I mean, in previous discussions, have you defined what encompasses a rover robot versus other robots? Like, is there a list of things that it needs to do to qualify for that? Meaning, we talked about you have wheeled ones, you have walking ones, or does it have to solve for both of those?
In the last discussion on this topic, which I led, I came up with a list to discuss, and it was biased towards things that were relatively more focused on the attributes of rovers. It was still kind of more in the general robot sense, but it was, opinionated in a rover direction. So not fully specialized to rovers, but at least partly. So I have that list somewhere in that page, I think. Yeah.
I'm trying to show the page now. Is this page right?
Yep. Oh, yeah. There you go. The desiderata list. So, for example, bottom up and situatedness makes a lot more sense for a rover because it's in an unpredictable wild environment, whereas it may not be as important for an assembly line robot for which the environment may be so controlled that you can just, declare it. So that's an example of this is kind of rover biased.
Yeah, but it doesn't matter if you have legs or wheels, or if you're a slug, okay, or a fish. Or all of those are rovers. So while at some level it's like the difference between having a hard disk and a solid state disk or using tape, it's still an operating system and it still has a file system and you can get and put and so on, if I'm mixing the metaphors a bit.
Right, but if it's one step forward, your operating system has to realize whether it's a step it's taking or it's turning the wheel.
Yeah. It could be a tail swish. It can be a hop. Okay. I mean, imagine if you have an audio only system, when you do hello world, it says it. It doesn't, display it. But the level of abstraction of what we're talking about, all of these are autonomous, semi-autonomous vehicles which are able to move around.
It strikes me that a good hello world type question that's safe and doesn't need safety behaviors is basically describing its body orientation. So unlike most robots, rovers are likely to have a sense of what's forward, what's backwards, what's left, what's right. We talked about this, I think, several meetings ago, and Rhett was working on a language for this, but that's an example of a rover specific thing where you do have like a relative spatial orientation in an environment. And you can imagine a command, something like, I don't know, orientation, and it tells you that, or it blinks the LED that describes its forward direction, something like that.
Why are you insisting that activity has to be safe? It has
You
to be
don't want your
simple,
hello
but
world to
not
kill the
safe.
robot, right?
If the operating system allows it, that's on the operating system.
Okay.
No, I'll tell you, my robot has a mode where you flip the robot upside down and then it can walk that way. So it also has, let's call it a command, which I disabled, where it quickly lifts up all its legs. And when it lifts up all its legs quickly, the body smashes into the floor. And of course, the robot shuts down. It has some sort of sensor which tells it that nothing good is happening. So that's a problem with the operating system. But as a command, it's very straightforward. So I don't mind if it's dangerous. I mind that the operating system allows dangerous commands, self-mutilation. Okay, so I'm just wondering why you feel that hello world has to be safe. That's all.
One of the key features of rovers is mobility. So can we have a hello world that is safe and mobile? Because as soon as we move, safety is like doesn't exist anymore. Cannot be guaranteed.
Well, I'm also I've been thinking a lot about Asimov's 3 laws, and so the second, or is it the third law, is it must preserve itself. So safety is like the third priority policy. So we're skipping ahead in the discussion, but as a reminder, the Asimov 3 laws are: rule number 1, it must protect humans or prevent humans from coming to harm. Rule number 2 is it must obey humans. And rule number 3 is it must protect itself. So in a way, if you wanted to do an Asimovian rover operating system, third law would mean that hello world is unlikely to be an unsafe command, which I think is it's a reasonable policy for most rovers. You might want suicidal robots, but it's a reasonable boundary.
Yeah, but that's on the operating system, not on hello world. In other words, imagine that you live in caves of steel and you get your new robot. So you want to see that the robot's working. So you tell the robot, you don't tell it stab yourself with a knife. You tell the robot, walk 2 steps forward. Now, if the robot is standing at the edge of a cliff, the robot should say, please don't make me do it, I might die. Okay,
yeah,
so
that's what I mean by that. So
no,
when I say it has to be a safe command, I mean the execution will be non-deterministic in the sense that it might avoid unsafe behaviors and refuse to execute.
right.
Just as when you certain Unix commands, depending on the context, it may or may not execute, right?
Right. But if the robot does jump off the cliff, you know that it was damaged.
It seems that this hello world question is looks very interesting and relevant. So I'm trying to express what I wonder whether we should not going a bit stepping forward on the operating system itself, and perhaps going through different of the features that we'd like to see and so on. Maybe that will help us try to identify the hello world, basically.
So I was curious. I was going to say, I was curious if NVIDIA Isaac has come up in the operating system discussion thus far. I don't believe we've ever talked about Isaac.
Yeah, it came up briefly for like a couple of minutes, but we didn't go anywhere into it really.
Yes.
It is a very interesting contemporary. Maybe I could dig into it a bit more myself. I don't know of it getting used in any deployments personally, but it does seem like it is actually going to be a framework of consequence, if just by brute force. It does seem that NVIDIA has the attention span for it. So between their hardware penetration and what it offers, it's a pretty serious thing. I was actually listening to a podcast talking about NVIDIA and RoS, and it was kind of bleak in a way, because it really just seemed like NVIDIA trying to make it clear that Isaac is superior to RoS in almost every way, in the breadth of the offering, and especially Isaac Sim's fidelity greatly exceeds that of the RoS gazebo. But so on the topic of definitions, though, they actually never call it an operating system anywhere.
Yes, the platform,
which is I find to be very interesting, because this to me almost is in compliance with even more of the operating system criteria that we've discussed thus far, and yet the marketing and the comms doesn't allude to that in any way.
Yeah, maybe an operating system is almost the wrong mental model to have it of it. Like, we don't have a sense of we are running an operating system. Like, we might make jokes about it that I'm running my engineer operating system or something, but in general, our sense of self, I don't think fits the mental model of an operating system as well. It's more like, an identity. So maybe I don't like the word platform either, because it's too lazily inherited from computers. But maybe something like identity system, like, maybe rovers don't have operating systems, but they have identity systems. So they have a sense of self, a sense of bodily boundary, a sense of like, when is that boundary being violated or not? That's all the things that go into human selves, right? And when people go crazy or paranoid or otherwise sort of have mental illness and breakdown, it's that sense of integrity of self that breaks down. Like, schizophrenia is that self splitting into more than one piece. A homeless person ranting in the street, they have like a weird sense of bodily envelope integrity. It might not fit their skin. So maybe identity is the right thing to try and build. Like, can you build and okay, now that I'm saying it out loud, I'm reminded of Hitchhiker's Guide, where the Sirius Cybernetics Corporation, which builds the robots and Hitchhiker's Guides, it advertises something called real people personalities. So that's why Marvin the robot has depressive personality, and then there is a door that automatically opens and closes, and it has a happy personality. So maybe identity and personality is sort of the thing that rovers need to construct.
This sounds orthogonal to the problems of not banging into walls.
I mean, it's a way of approaching the problem of not banging into walls. Like,
How so?
depending on the identity and personality, if you tell it take one step forward, a robot that has like a very polite, depressive personality might say, "Oh yeah, what's the point of life?" and might walk off a cliff. Whereas a very happy robot might say, "I would prefer not to," like in the
Right.
Odyssey 2000 movie, right? That famous line. I'm afraid I can't do that. What's the name of the guy? You know what I'm talking about.
Yeah.
Yeah.
Robert or something, I think is his name. But yeah, so personality is one way to approach the problem of setting universal policies that allow you to respond to particular commands like take 2 steps forward, right? Like you can have a very angry, rude type of robot that says, take 2 steps forward, and it'll be like, give me money or fuck you, right? All those are valid responses if you approach operating system, instead of operating system, you approach personality system or identity system as the thing to build.
It's interesting how identity moves more to the self and consciousness and such kind of things, because we have this romantic view of on robots, maybe not romantic, but no, actually, it's more about the slave view of a robot, where it's the original absolute servant, right? Which still has an identity and an enclosure, a self, which becomes explicit compared to the thinking of an operating system. It's interesting also how terminology can trigger long discussions, right?
But we're not arguing, terminology. It's not, I define it this way and you define it that way. It's more, what kind of things do we fit in the woods?
Oh, yeah, sure. Yeah.
Oh, we could argue terminology.
Yeah, I think this is a very useful discussion because depending on which of these mental models we adopt, we might end up doing extremely different things by way of like early experiments, right?
Yes, exactly, yes.
So one thing that is I would consider to be a contemporary, kind of like a contemporary robotics problem is multi-agent systems, multiple robots in coordination. This is something that there's no one thing that anybody points to. There's a lot of small companies trying to figure out and coordinate this. Usually comes in many shapes and forms. One thing that's needed is the notion of like air traffic control. There's that problem. There is the fleet management problem. Actually getting software deployed and maintained and updated on multiple robots becomes a whole task in itself. There's a health monitoring, fleet health monitoring question. But this all requires, usually, especially the air traffic control, requires a real time kind of like it's a single robot. If we're talking, this is a system boundary question. Is the robotic system the actual complete fleet, or is it just a single robot? And this is something, like I say, there's no one thing that people really point to. RoS can certainly makes it easy to communicate between robots, but it doesn't necessarily offer anything out of the box to solve any of these tasks that I mentioned. And there, like I said, there's a bunch of small companies that are trying to make it easier when you have multiple robots, but it really is, it's an open question.
Yeah, you mentioned companies, but academic work I know has been going on since the early 90s on exactly these questions.
Of course, but we are just now starting to actually see commercial applications of robot fleets, not just defense research and academic research. We're actually seeing this, and there was certainly the sidewalk delivery trays in the past 5 years. There's the kind of canonical example now is fulfillment center swarms or Kiva systems, and now Amazon Robotics. That's the canonical example of a traffic control problem.
Mm-hmm.
But as there are more and more robots out in the wild, they are going to need to start interacting with each other in this way. And especially if you're talking about rovers in a remote area, I do remember somebody was talking about Kubernetes with a resource cost function between rovers. And that's the kind of thing where this becomes critical if we're trying to deal with resource scarcity and schedule across the fleet of compute, not on a single robot.
But that's what I'm talking about. The research, academic research I'm talking about, that is what it deals with. Rovers, doing air traffic control, talking about the health. Are they able to do a mission, negotiating the mission between them? So I'm not saying anything about the real world, okay? But in academia, I know it's been going on for quite a while. There could be some missing connection here.
There is a big gap between at least the work I'm aware in academia from the 90s too, and the real applications, honestly, because most of the work, in fact, one of my PhD advisor has been working on multi-robots since the 90s, and he's still working on that. But I remember all his work was done in simulations. And recently he founded a company to apply a lot of his research on drones, okay? And by his own words, it's the gap is huge on making all the models, which he got prizes on those works. There is a lot of frameworks that have been designed and so on, but what I guess what Joshua is coming to is that there is a big gap between what has been done and how to bring them to reality. We see the same thing with deep learning. Deep learning is from the late 80s, early 90s, but it was we had missing pieces to get anything in. The basic frameworks, basic thinking behind deep learning is understood for more than 20 years. Okay. For more than that now, 30 years, right?
That's exactly what I'm asking. I'm asking,
okay.
If you can identify the gap. In deep learning, the gap seemed to have been simply processing resources.
And data availability. So it's not simple, actually.
Nothing simple.
I think the gap is closed
well, yes.
in deep learning. Like I think we could probably just call that, like, the gap is closed, but the gap is still very much open with the multi-agent system stuff. And I think that's, maybe there's an opportunity to start closing it now, now that things are getting really cheap. But yeah, completely agree. It's been yes, I understand this has been around for a long time. That's just my point, is I can't really point at any one set of tooling or frameworks which is implemented that of the academic research maybe 10 years ago from the simulations.
Yeah, this was actually my field in both my PhD and postdoc. And I remember sitting in on one of the earliest multi-agent system courses that was offered at Michigan. The instructor was Ed Durfee. He was on my committee.
Yeah.
And we read a bunch of the academic papers. There's a book that the first edition came out at that point. I'll post it in the Discord. It's by Wise, and it's called Multi-Agent Systems. But the gap, I would say, is a very different kind of gap than in deep learning. Like if you first were introduced to like neural nets and multi-layer neural nets in the early 2000s, and then you encountered the literature that emerged after about 2009, the gap wasn't actually that much. Like Meyer says, it's basically all right. It's the same thing running on lots more computers and lots more computing power, but the concepts, yes, there was a little bit more here to read, a little bit more here to understand. Some of the, it went beyond backpropagation and some of the basic techniques, but basically it was a straightforward extrapolation, and the gap was like just doing more and better. Whereas with multi-agent systems, when I look at the snapshot I had in about, when did I take the course? 2002 versus the earliest Kiva robots. So my postdoc advisor was actually the architect of the Kiva robots. And that gap, I would say, was so big that it basically turned a lot of what people thought they knew through theory and simulations into kind of like cute philosophy garbage. It was like a lot of that stuff in the 90s and very early 2000s, it looked closer to me to like, political science, game theory experiments, iterated prisoner's dilemma, that kind of like stuff, logical conundrums of like multiple agents like coming up with a joint plan to do something. And then when you looked at actually what the robots did and what Kiva robots did, it's like they were working on entirely different problems. It was not just like, more or faster versions of the same problems. Like literally they were working on completely different things. So I would say, despite the similarity in the names, I would actually completely distinguish them as pretty much different fields. Like multi-agent systems in the sense of the 90s and early 2000s is basically a different field than the one that emerged after the first practical fleets came out around 2008 or so, because there's too much that was different. Like, but if you ask the people, what are the top 5 most interesting challenges in multi-agent systems in 1998 versus 2012, you would get completely different, like, apples to oranges level differences in what people said.
A lot of this has to do with the compute scarcity and just how stupid robots are even today, though. Behaviors that can become a bit more interesting, I would think emerge as we really start to deal with much more interesting scenarios and very high levels of autonomy.
Yeah, I mean, once we get to enough computing, like all the like swarm algorithms that we were working on in simulation, yeah, they become valuable, but it's still at the level of like, I'm trying to think of the right. Okay, here's my analogy that I think works. If you study political science and you go to a political science textbook, one of the first things you'll learn about is like, the Hobbes versus Rousseau versions of like the origin of the state, right? Hobbes, state of war, fight of all against all. It's a very theoretical, abstract thought experiment on how civilization emerged. And then you go to Washington, D.C. and talk to politicians about how policies are actually made and how bills are crafted and pushed through Congress. It's like, at some level, they're not even the same domain. Like making policy in DC has nothing to do with analyzing the Hobbesian state of war thought experiment. They are related at some like deep level, I guess, philosophically, but one doesn't really help the other that much. So that's, I would say, the what the gap to me looks like between the academic theory of multi-agent systems and what we're facing right now.
I mean, the example I would make is something like at least for me, when I think of a multi-agent system, the canonical example is like the Boyd's algorithm and how you can formulate a set of core laws that explain some emergent phenomena or navigational pattern of systems of multiple agents. But then you actually deal with drones, and they're so incredibly, they lack, the real world has such low fidelity, and the man-made real world has such low bandwidth and fidelity versus the natural world that like the dexterity and agileness of a robot compared to a bird is still a huge gap. So it's not even worth mentioning what the algorithm could potentially do with robots. But I mean, that's really just, that gap is the gap between nature and man-made right there. And that's what I mean, is that's what something that I see closing a bit as, you know, all of these robots become kind of like little animals in a way that can kind of little donkeys and things. Like they become autonomous systems. They're just very primitive.
Yes. And something very interesting based on that, Joshua, is that multi-agent systems in the 90s and the early 2000s, but even now, I remember a lot of conflicts in the community because of the misunderstanding of what decentralized control was meaning, what it meant, and whether it was even useful, basically. Because a lot of people in multi-agent systems, for example, you mentioned about putting some rules and so on, and see what happens, okay, like in a swarm and so on. That implicitly assumes that we have a kind of godlike position where we can view everything, we can decide everything, and it's like basically, we drop something, we know it will fall, and we drop many things, they will all fall together. Basically, it's like just looking at the things this way. And most of the work I've came across when I was I've been in that community for about 7 years, okay, and connected from outside since then. Very few people were talking about first getting real, and second about decentralized control. Everything was implicitly centralized control with a kind of master algorithm somewhere, including work on multi-robots, by the way. Sorry,
by the way, I think,
please.
Yeah, I would say just like that in itself is still a non-trivial, unsolved, out of the box component in these, ROS or Isaac or any of these other things. If you would like to have a master controller in a fleet, you have to set up some server somewhere. It's not like you can just have a virtual hostless master that gets handled by some middleware that allows you to have a centralized control of the fleet, but it is in fact running on one of the fleet nodes. You just don't know which one. That's like something that doesn't just exist and is easy yet.
Yes, that's very interesting. It's that that the client server infrastructure remains okay.
Yes,
and there is
that's right.
It's like the internet. A lot of people see internet as the paramount decentralized system until we know how DNS works, basically. Because basically DNS is, to put it simply, okay, it's a hierarchy of servers that have a special role, and without them, the internet just doesn't exist, basically. Okay? We have root servers on the DNS trees of servers. And if we are at the top of the, I don't know how many roots there are. I don't think it's one. I think it's a handful. Okay, and there are some geopolitics around who's owning the root servers and so on. Okay, but it's the internet is actually a centralized system at the root.
By the way, as an aside, this debate has just started in Web3. Like, there's this popular blog post by Moxie that just got published, where he basically makes the same criticisms that Web3 people are talking about it all being decentralized. But if you actually do a double take, you realize that there's just three single point failure Web2 style companies that are gaining access to Web3, and MetaMask is a single wallet that controls all access. So yeah, I mean, some of those debates might actually be kind of interesting, that we might be able to get to truly decentralized robot systems in a way that you can't do with the internet in its current form, because you still need like DNS type systems. But maybe with robots you can, because everything at some level is a role played by one of the robots in the multi-agent system.
But we do call in internet architecture, we do call it an AS, right? It's an autonomous system is a block of the internet. I actually forget what the technical criteria is for an AS, but that is the jargon in the internet architecture.
What was the name? It's interesting because recently we've been talking about blockchain, and now we are talking right now about decentralization in the context of the operating system. Yesterday, Maya and I had a chat about some of the things that could be part of an operating system, and again we talked also about blockchain and so on. Okay. There's something that's around here, or maybe that makes actually blockchain technologies. I'm not talking about Bitcoin and so on. I'm talking about the technology here, as the blockchain as possibly a first level entity inside a Rover operating system. I think Venkatesh, you talked about something like that at some point, no?
Yeah, I think it would be a very interesting intersection that nobody could have thought of like 15, 20 years ago. So it's one of those very fertile intersections that we should definitely explore, because it allows us to like some of these problems Joshua mentioned, that right now you have like some master controller running as some host on some rover somewhere. That sort of thing is, I think, I don't know, very elegantly solved by blockchains. And you can have like, a contract that's run by the Rover blockchain, and you have like assigned roles and people vote for a leader and one robot gets voted as the leader. All that sort of becomes conceptually elegant if you use a blockchain-based system. So yeah, I would definitely be interested in seeing an operating system where a blockchain is a first-class citizen conceptually.
Thank you. In the discussion section, so this slide, you can still see my screen, right?
Yep.
Yeah. So perspective and teaser was what Venkatesh already talked about. But actually, I think Venkatesh will be talking more extensively later in this cycle, right?
Yeah, I made a page on Rome for just your initial starter thoughts on the 3 laws. But yeah, I was thinking I'd do that as a special topic in my session in a few weeks.
Yes, thank you. And so just a proposal is that, Meyer, what do you think about getting through maybe the what we talked about yesterday about what should a rover do at boot up and when it shuts down, basically? Because it's I see that personally as an exercise in okay, what do we need in a Rover operating system? What kind of making a kind of it's a brainstorming list with a bit of structure about what could go inside that. What do you think of that? We're already 1 hour and a half inside the meeting today.
Well, there's no time today.
So next week,
but then we have to move the what's it called?
Licensing
issue.
Yeah. Is there interest in everyone? Is there interest in talking about to talk more about operating system next week, or more interest in licensing? After I will arrange the schedule.
I would prefer to continue talking about operating systems. The licensing thing seems like a project management topic that is a chore to get through.
Unnecessary pain, right? Is this interesting to everyone to continue next week on operating system? Concretely, to talk about more concrete stuff.
Sure.
Yeah, I'd be happy to talk more about this.
Right, so we are just 1 hour and a half mark, so perhaps we can wrap up for today. And as for the slides, so there are notes in notes, but basically we covered most of the slides. Okay, the goal was to trigger discussions, and I just added this slide, which was basically from the previous from the kickstart. Okay, it's about we're talking about operating system because it's an important topic, but it's also software, and so there is an opportunity for collaboration among us. Okay, and so here I tried to put several possibly interesting points. And what is pleasant to me right now is that a lot of things we talked about can be retrieved here. Okay, and so there is nothing more about this presentation. But just to close, so next week it will be January 18th at the UTC time, maybe 17th on the West Coast. And so Meyer will be talking about maybe an update of his build, and so not licensing, but more OS stuff. Is that pleasant enough for next week?
Sounds good.
Yeah. Exciting. Any closing note? Any announcement? Or we wish a good night to people who are waiting.
So is the goal to identify a good candidate to use as the operating system, or are you considering like rolling your own, or?
We're considering writing our own, but we keep an eye on existing stuff. And typically, this was this slide where we talked about RoS extensively, and RTOS and so on. And so the discussion may have been a bit fast today because we've been discussing that for a while. Okay, but the thing is that we see shortcomings in any of these approaches. Okay? And the shortcomings are with respect to be able to run a common piece of software, ideally for all of us. How diverse our rovers can be, we can still rely on the same base software, on which after we probably need to make some specialized code for our build. Okay?
So, but it's to identify an operating system, or sort of come to a consensus about what to use, so on future builds we'll all be in sync. Is that correct? Okay.
Yes. Yes. I don't think we want to reinvent too much wheel, but it seems that here there are interesting things that actually just don't exist. And maybe some exist, but they are not put together inside what someone would call an operating system.
Right.
So a concrete example is what Joshua talked about, multi-robot facilities. So whether or not it's part of the operating system is still open, I believe, but there is academic research on mechanisms, protocols, and so on for that. But there is no readily and usable libraries for that, for example. Yeah.
Okay. I mean, I guess is there any, I'm just starting out here. Should I spend any time looking at RoS or investigating RoS, or is that just not a good use of time?
You should.
I would just give an opinion. Please.
You
Please, Mayor.
definitely should look at ROS. ROS is trying to solve important problems in robot control.
It's the state of the art.
Okay, okay. It just sounded like everybody was not happy with it.
Well, nobody is.
We're happy to have it, so we can be unhappy with it.
Okay. All right, thank you.
But to give you an example, here I'm working with about 20 robotics companies in Japan, and maybe 2 of them are actually using ROS. All the others, they tried it and they don't want it for various reasons. The 2 reasons that came back most often are poor error handling from their perspective, and very difficult to get proper monitoring for their robots. Okay? Here are, yeah, it's just an example of the kind of feedback I got on ROS these days.
Okay.
I mean, this feedback is 2 months older for the oldest one. So
everybody has
unhappiness.
Yeah, everybody has an opinion about ROS, but it's all anybody talks about because that's the primary candidate. So
Okay.
Yeah.
it is this interesting cycle.
Okay. Well,
The thing that
that's-
ROS, historically, ROS is an enabler, because before ROS, it was people were even more unhappy, right?
I guess everybody's doing their own thing.
Yeah, but just notice is ROS1 and ROS2, they have the same name, but they are quite different.
Okay.
Yes.
Okay, and ROS1 is much more commonly used and talked about and has features added to it.
A large complaint by at least in the industry, ROS1 is largely not considered to be good enough in a production environment. It's flaky.
Yeah.
So then everybody got together and said, we need to make it not flaky anymore. So then ROS2 came along. And now the issue is that everybody has a lot of libraries that are written for ROS1, and it has all of the things out of the box that make it easy to prototype robots. But ROS2 is more robust and reliable, but nobody wants to use it because none of their libraries work on ROS2. So then there's only highly incentivized and well-funded industrial companies that are using ROS2. And then all of the small companies and academics are using ROS1 still to this day because that's what all their old code is running in. And so now there's this big divide between ROS1 and ROS2. And this is the cycle of ROS that we're kind of currently in.
Got it. Okay. All right. Thank you. All right. Well, sorry to keep you guys
So
up longer.
what would be the advice to start with? To start with ROS1 or ROS2 at this point for Brian? I would recommend ROS1, okay, but ROS2.
Honestly, I would say ROS1, yeah, because there's more examples.
Right. Right. Okay. All right. Thank you.
Pleasure, but it's great. If you become the group ROS expert, you know, that's great in many senses for the understanding the depth of the comparing to what we are doing and so on. And also we will have someone to complain to, so it's great.
Well, we'll see. That's a lot there. They do. Thank you.
Now, ROS has been it's a milestone in the robotics industry. Okay? It's clearly a very important player.
It's the longest lived single output of Willow Garage. It has tested. It's survived the tests of time, and so yeah, it's the longest lived output of Willow Garage, which was kind of the beginning of many things in robotics.
Indeed, yes. And the people from there still continue on their own now, huh? Yeah. And fortunately, ROS did not make money for them, huh? It's a pity.
No, but They got a lot of good stories out of it, at least.
It's complex, but it's definitely a milestone and an impressive piece of work.
Okay. I look forward to it.
All right.
So
Thank
yeah,
you.
thank you very much. Good night to
Good night.
Well, you're up the latest.
and good day to Dave.
Take care.
Thank you very much
See
for your
ya.
time.
Bye-bye.